Alright, so for this video, I want to go ahead and go over question 4 on the pre-calculus review packet. So we're going to apply the same ideas that we investigated in questions 1 and 2. The only issue here for question number 4 is that it is a little bit tricky, so be real careful with this one. Once again, there's different ways to think about this problem. I like to think about it one way, but there is a more efficient way of completing question number 4. So we want to use the same idea we looked at in question number 2, where we multiply by a shared common denominator in each term. So notice here, if you look at the numerator, this term has a common denominator of x plus 1, but this other term here has a denominator of x. So once again, x plus 1 is a denominator here, and x is the denominator for this term. So the idea when you're using this more efficient way of simplifying this expression is to multiply this whole algebraic expression by each of these denominators. If you go back to question number 2, there was only really one denominator that was present, and that was x plus 2 in question number 2. But here in question number 4, we have different denominators that we have to take into account. So for this question, you're going to want to multiply this whole algebraic expression by x times this other x plus 1. And then we're going to put that over the same thing, so x times x plus 1. So don't forget that we multiply the numerator and the denominator by our shared common denominator. So be a little bit more careful here, but we want to use the same ideas that we use in questions 2 and 1. You're going to want to distribute this term into each of these. So if we move forward with this, your numerator should look like this. So we have this whole term times x. So you have x squared times x plus 1 over x plus 1 minus x times x plus 1 all over x. So that's just in the numerator. And we're going to have all of this all over this. Distribute that into each one. So you should get x squared times x plus 1 over x plus 1 plus x times x plus 1 over x. All right, so at this point, you want to ask yourself, is there anything that we can cancel? And notice here that there is. So I'm circling these right here. And we'll go ahead and cancel those out. So that cancels, these x's cancel, this cancels, and lastly this cancels. So now our expression should look like this. We have x squared, and be super careful with this negative sign is going to be very important, so make sure you write that down, minus, and make sure to put this in parentheses x plus 1 all over x squared plus parentheses x plus 1. And if we simplify that even further, you should get x squared. We'll distribute this negative into each one of these terms. So x squared minus x minus 1 all over x squared plus x plus 1. So at this point in the problem, you'll notice that we have quadratic expressions right here in the numerator and in the denominator. In some types of problems, you have to ask yourself whether or not you are able to factor these quadratic expressions. One way to figure that out is by finding the discriminant. So discriminant of a quadratic expression. And I just want to let you know this, but this top one is actually factorable. But if we look at the bottom one, x squared plus x plus 1, let's find the discriminant of that. And the way we find the discriminant is by using b squared minus 4 times ac. This b is going to be this coefficient. A is going to be the coefficient in front of x squared, and c is going to be your constant. So just recall, we have 8x squared plus bx plus c. So once again, a is in front of the x squared term, b is in front of the x term, and c is just the constant term. And what you'll notice here is that if we find the discriminant of the bottom here, your coefficient of b will be 1. Your a would also be 1, and your c would also be 1. So if we plug in these coefficients into our discriminant, you'll get 1 squared minus 4 times 1 times 1. And what you'll notice at this right here, whatever you get here, which is what, 1 minus 4, which equals negative 3. What you want to look for is your discriminant either greater than 0, equal to 0, or less than 0. In this situation, our discriminant came out to be negative, so therefore our discriminant, I'll just call that D, our discriminant was less than 0 because we got a negative for it. And whenever your discriminant is less than 0, that'll tell us that this quadratic expression that we looked at in the denominator has no real solutions. So because it has no real solutions, it is not factorable. Okay, it is not factorable. So therefore, if you go back to our algebraic expression here, this would actually be, this would actually be our final answer. And just an FYI, this is also going to be very important. So once again, if our discriminant is less than 0, you'll have no real solutions. Because of that, it isn't factorable. If your discriminant is equal to 0, you'll have one real solution. And then if your discriminant is greater than 0, you'll have two real solutions. So whenever you have a discriminant equal to 0 or a discriminant greater than 0, you'll have these situations. These situations are going to be actually factorable. And there's different ways to go about doing that. But in this video, we won't go over that. But once again, I just want to kind of remind you that when we're talking about solutions, all we're thinking about is when does this quadratic expression hit the x-axis. So if you look at this little graph that I made, those red points right here are called our solutions. Okay. So once again, this right here would actually be our final answer. And I hope that this is helpful. I know that I brought in this idea of discriminant, but it actually does help in these types of problems because in some situations, there are situations where you are able to factor a quadratic expression and you're able to actually simplify even further more than this. But in this situation, since the denominator is not factorable, this would actually be our final answer.